Okay, this lesson's on some general info on position time graphs, which we'll be using in many of our labs this year. So what we see up top is just going to be a simulation of a man that could walk in any linear direction, positive or negative, which I'll control. Below we see a position as the dependent variable and time as the independent, and we'll begin graphing in one moment. And first I'm going to start by uh, making this man move at a constant velocity. So let's watch what we get on the graph with a constant velocity. Alright, a couple things from some basic motion. Number one, before I started moving him, our graph stayed flat, so a slope of 0 on a position time graph obviously represents that I have not moved yet, or I'm staying at the position just shy of 5 meters. Then I chose to move at the best constant velocity I could make with my hand, which isn't bad because I get a nice linear slope, and it's negative because he was moving in a negative direction. So what does that tell us is that the slope of a position time graph is actually where the equation for average speed or average velocity comes from. As you know from algebra or even before that, slope is equal to change in y over change in x. But when we apply this to a position time graph, change in y is actually distance and change in x is actually time. So that gives us the equation v equals d over t. And at the end of the trip, I stopped again and flatlined out at about negative 4.6 meters. And there's a few basics about what linear lines mean on a position time graph. Next, I'll quickly try to show you acceleration. This is a little trickier with making a move myself, but we'll clear this. I'm going to try to do a uniform acceleration rate next. And it looks like for the time interval from about 2 to 4 seconds, I had a pretty decent, or even a little bit past that, curve in my graph. Any curvature, whether being up or down, on a position time graph, any nonlinear portion represents some sort of acceleration. Which we'll learn those equations in a little while from specifically a velocity time graph. But you can still see and represent on a position time graph uniform acceleration by watching if there's any nonlinear curves. So basically, to sum everything up, what we end up having is flat line on a PT graph is that you're not moving. Linear slope upward means you're going at a constant positive velocity. Linear slope downward means a constant negative velocity. And a curvature, whether it being up or down, is telling me that I have some sort of acceleration going on. And just one last thing to note is a question that we sometimes get is, can you be completely vertical? We said horizontal means stopped. Vertical, if you could imagine, we can't actually do it, but if you could imagine a graph line being vertical here, that's actually impossible. A vertical line would show that I'm in many places at the same time, and we all know that to be impossible. You could approach vertical by going faster and faster and faster, but you can never really get there because nothing, even something as fast as the speed of light, cannot be in two places at once.